You want to make comments about people? This is the thing. I mean, it's basically just sort of a question of getting as much recollection as on. I mean, can I just start off by getting you to tell me your name and how you actually came to be working at Westcott?
Okay. Now?
Yeah, whenever you're ready.
I'm Stuart David Marsh, originally from Liverpool. I had an interest in things military, things that exploded in rockets and in space travel. That was just an interest. My original aim at school was to become a pharmacist. Part of that was A-level biology, which included a lot of things to do with plants, and I just couldn't see any point in studying plants when I was going to look at the effects of chemicals on people. So I just lost interest in that. I became more interested in the physics, chemistry and the maths side. Anyhow, my mother was, I think, getting fed up with me being at home with no prospects for a job. So I started to apply to various aircraft and the scientific and engineering parts of the Ministry of Defence and the Army departments and so on. And I got the offer of an interview at a place called Westcott, which was near a town called Aylesbury, famous for its ducks. I had no idea where it was. I knew nothing about it. Anyhow, I came down for the interview and was asked, to me, very searching questions because I'd never been on an interview before that. I must have done reasonably well because I was offered an apprenticeship, a drawing office apprenticeship. I really had no idea what to expect about that, but I thought, well, yes, take it. With, of course, the backing of my mother. She was keen to get rid of me, so that was it. I started work at Westcott in September 1962. And that was in the first year apprentice shop. That first year was devoted to learning the basics of machining at Westcott. We also did day release for the theoretical side of engineering, and there were 2 evening classes as well. I did the full 5-year apprenticeship because I started at 18.5, not 16 like most of the others. I managed eventually to pass ONC and HNC. That was a hell of a struggle, but I did manage through my apprenticeship. As I say, the first year was mechanical engineering in the apprentice workshop. The next, I think, 2.5 years was spent 3 months in various departments: fitting, turning, milling, site work, metallurgy, planning, inspection, really learning the basics of mechanical engineering. The last 18 months of my apprenticeship was spent in the drawing office. First of all in the apprentice DO, where we learnt the basics of drafting. Then into the main, design office to learn design. And it was draftsmen then who taught us. Everyone there, throughout my apprenticeship, everyone was eager to teach me. Everyone was eager to explain. And this, in retrospect, I find this, or in hindsight, I find this absolutely amazing. People were prepared to help you, not to give orders, anything like that. I think a lot of that was due to Westcott being a scientific establishment rather than an engineering establishment with the tugging of the forelock and the cloth cap image, which I think was valid for some of the ordnance factories. Anyhow, after my apprenticeship, I then moved on to one of the main sections in the DO, which was engineering services. Again, the same people who taught me the basics of engineering kept on. They helped me, they nurtured me. Variety of people, variety of personnel, a variety of work, a very good grounding. Then I think I was up for promotion. My career then progressed. I think I was in the right place at the right time, rather than any special merit that I showed. And I think people have always seen more in me than I have ever seen looking at that face in the mirror every morning. Anyhow, I progressed from the engineering section. I moved on to the liquid engine section, was promoted to leading draftsman. I was then promoted onto senior draftsman with liquid engines, and I really stayed with liquid engines. There was a very odd thing. A drawing office manager was brought in, an outsider, and he wanted, I suppose, to build his little empire. Very embarrassing thing was a job vacancy for a senior design engineer occurred, and I was expected to put in for it. Lots of people said there were things missing from the job description, like has to have a Liverpool accent, has to wear glasses, has to be 5'10", various things like that. But the job was written for me, and I applied for it and I got it. I'm not going to turn something like that down. After that, when Westcott started to shrink, the then chief draftsman resigned, and I applied for the post of chief draftsman. I was then chief draftsman for, I think it was about two and a half years, maybe a little bit longer, until 1993, when I took early retirement. The offer came. Throughout my career at Westcott, I had been involved in the design, manufacture, the development, the testing of a lot of mostly liquid engine projects. Things like the PLTV series of packaged liquid systems. I was also involved on various schemes for future work, as well as the thing that kept Westcott going, or liquids going for ages, the Cheveline project. Not sure how.
No, shall I stop for a second?
Yeah.
Okay.
As I said, I worked on the engineering section in the DO to start with. That was making, producing designs for tooling, for things like valves, site components, thrust rigs, inspection equipment, machining fixtures, inspection things. I think I've already said that. And again, it was a variety of work, all of it mechanical engineering, not electrical, because there was a different section in the DO that did electrical and electronics. Again, I was very gently led through things with somebody standing close by, looking over my shoulder. Then they moved further and further away until I had to go and find people to ask if I wanted help, wanted information, or I had made a complete mess of things and dug a big hole and just couldn't get out. The liquid engines section at the time was devoted mostly to packaged liquids. That was basically nitric acid and hydrazine-derived propellants. By the time I was in the DO, the cryogenic work had stopped. There had been some liquid hydrogen work that I'd worked on the engineering section. That was only valves, transfer lines. That disappeared, and it was back to the storable propellants. That consisted of the PLTV series of flight test vehicles, package liquid test vehicles. At the heart of those was a Cordite gas generator and two propellant tanks, one for oxidant, usually nitric acid, red fuming nitric acid. The other was hydrogen-based MAF, mixed amine fuel. There was a lot of work done on those, on combustion chambers, on the tanks themselves, which were piston fed, the Cordite generators. There was then work done on IPN gas generators, isopropyl nitrate gas generators. The problem with IPN is that when it's compressed quickly, sort of with a hammer blow almost, it's liable to explode. I forget, I knew it was explained to me what happened, but I can't remember it. That'll be in the literature. There was then a lot of work done on removing this, and the way to do it was to blow, I think it was something like methane, butane, propane through under a vacuum. This removed any air that was dissolved in it. It was then safe. You could use this for a gas generator, and that was done. Again, it was a piston expulsion system, cordite to provide the initial heat, and then it was self-sustaining. It was a bootstrap. After this was developed, it was then used on, I think, 2 of the PLTV series, which were successful. It then seemed as though that was going to be the end of liquids, because liquids aren't used on the battlefield. Liquids were used for space launches, satellite launches. Britain, for whatever reason, had pulled out from that. Britain was prepared to provide the money, the finance, but not any of the hardware. The saving for liquid engines came with the Cheveline project, which was an update of the Polaris system. Westcott's part was to provide a propulsion system, a sort of third stage, I suppose, boost system of some sort. Because this was going on submarines, it was ideal to use packaged liquids. And I think, again, it was inhibited red fuming nitric acid and MAF1. It took about 10 years or so from the start through to the development and the testing and then the production to see it in service. The hardware itself consisted, for liquids, was PLTV. TCPU, Twin Chamber Propulsion Unit.
Do you want to pick that up? Do you want to start that bit again? Just say the propellant was.
Right. In the Cheveline system, at the front end there was a boost system. That was the liquids part was TCPU, Twin Chamber Propulsion Unit. It was actually like 2 completely separate propulsion units. Fuel and oxidant tanks in tandem, duplicated, each with its own chamber. The idea was that both the tank systems fed one liquid engine. At a certain point, that was shut off. At another point in the flight profile, the other chamber was powered up, and that there was a lot of problem. There were a lot of problems in the TCPU that weren't found on site. I think the problem started with flight when rounds were blowing up. It was believed that what was happening was hot fuel-rich gas was leaking past the pistons into the oxidant tank. So you got hot fuel and oxidant. That caused a chemical reaction, the burning, overpressurized the tanks, which then burst. But this problem only happened after the TCPU had done its job. So it was a problem, but it could be lived with. It had to be lived with, because I don't think, after spending ages trying to reproduce the problem, we did eventually manage to do it, but I don't think it was solved. It was just a problem that happened at a later stage, and that was it. After that, there was some work done on work with hydrazine, inhibited red fuming nitric acid and hydrazine. Again, this was done for satellite propulsion systems, and Westcott, after Cheveline, went on to produce a series of 100-pound thrust satellite engines. And these were very successful. The, the design was based on a design done by Aerojet in the States, but Westcott's contribution, which was quite earth-shaking at the time, was to produce the injector as a bolt-on injector for testing. This was then matched to an engine, fired, tested, everything was cleaned up. Then the injector was welded to the engine. So the customer knew that they were getting a proven system. These engines were sold, I think, to the States, to some European countries, and I think they were very successful, those. They were also, I think part of the thinking may have been, if these could be sold to Europe and the States, it was a foothold for the States to get into Europe. They were using European-sourced engines. I think this was possibly, I don't know about this, but this may have been the reasons why the company that I know as Bell Aerospace, I don't know what they were called when they eventually took over, why they bought that. It was a foothold for American aerospace to get into the European Space Agency, which at the time, and still is really, is ruled by France and Germany. Stop.
Okay. Okay, running.
As I said, I came to Westcott for an interview. It was there. There's two people on the board were the chief draftsman, Jack Lorillard, and the chief engineer called Holder. Jack Lorillard, but well, everyone on the board, to an 18-year-old who'd really had been, who'd only been in the school system and really hadn't had a life. This was awesomeness, to be faced with these adults who were going to ask questions. One of the questions that I do remember, and it may seem very petty to you, may seem very small, Jack Lorillard asked me what x to the power naught was. I had no idea. I'd met indices, I'd done x to the 1x squared, 7 cubed, things like that. I had no idea what this naught was. Anyhow, Jack asked me to do it from first principles, and he led me through this. At the end, I found out x to the naught was 1. It then struck me, I said to Jack, or Mr. Lorillard at the time, anything to the naught, anything to the power naught is 1 then, isn't it? And I think I must have beamed with delight. I'd actually worked out something from first principles with help, and I think that was possibly what got Jack on my side. I think he was very helpful, that. And I found in later years, he was a marvellous person. He was a very awesome figure. I suppose patrician would best describe him to an 18-year-old, 19, 20, whatever. It was only until, I suppose, his last year at Westcott that I got to know him and realised that he was a marvellous individual. There were others in the DO. Really, that was almost everyone that I came into contact with who was really nice. It's an overused word, nice, but that describes them perfectly. There was one individual, though, who was loathed, I think, by everyone, not just in the DO. In the workshop, he was loathed. Petty little martinet, a bully. He's now dead, so I'll name him Fred Page. He had no abilities as a designer at all. Well, that's okay, you can work around that. He was a senior draftsman, but he was an administrative draftsman who thought he could design. He just knew nothing at all about design. He knew very little about administration. He certainly knew nothing at all about people, how to get the best out of people. again, as there were other people, when I was doing my apprenticeship, came across a lot of the actual workers, the workmen, the machinists, people who swept the floor, things like this. And again, these were people I had never come into contact with. It had been people who worked in shops and teachers. That was my only experience. And then to meet all these people who, regardless of their job, would say hello to me and talk to me. Amazing, this. And they all helped my development. The good bits of me are down solely to them, not to me. I had very little in that. I soaked up all of this. The bad bits I still retained. Well, hard luck, that's me. I'm not going to change. It's a bit late, that. But throughout the time at Westcott, there was an air, not of excitement, that goes too far, but an air of, yes, let's do it. Not the American wave flags or anything, just a sort of relatively quiet, relatively understated British way. Yes, we can do it. Why not? Give it a try. There were times when things failed, when things blew up, when things broke, when they didn't fit. But that happens to anyone. But there was, as I say, for me, certainly excitement. There were new jobs. There were some things that I had no idea how to do. Again, people helped. Not just people in the DO, not just the draftsmen, not just designers, people in inspection, people on the shop floor saying, why did you do it like this? They made me think all the time. And that was, again, another thing from that. I was made to think and to come up with answers, or to say I don't know, but never to say no, always to go further, to try, to push. I was also encouraged, as were the other apprentices in the DO, to find out, ask people what they're doing, why are they doing it. And I was told by one leading draftsman, who really was my mentor in the DO to start with, if someone told me to go away, maybe forcefully to go away, to come back and see him, because I was there to learn. And I was told, the sort of, the homily, you never stop learning, and that was quite true. Again, it's all these phrases and sayings, mostly of which your mother says. They all come true, and that was one. As I went through the DO, through the various promotions, I realised that it was what I had to do was carry the torch for previous leading senior draftsmen, chief draftsmen, machinists, charge hands, all of those. I was there not just to do a design job, but to help others, to teach. And part of my work was teaching apprentices the basics of drafting. Some were good at it, some I knew could make it, others just weren't interested. So I gave them, the idea was give them an easy ride. They had maybe 6 weeks of rest, of doing homework, whatever. They still had to do certain tasks, but they were never going to be in the DO. So long as they could read a drawing, why bother wasting my time and their time on it? Again, that was something that I learned from others. You don't just throw somebody away, but find something that they can do, something they're interested in. And again, as I progressed, as I was promoted, I was went to various meetings, not just with Westcott people, but with people from other establishments and outside industry. Got to know how they thought, and there was a difference in thinking between certainly Westcott and outside industry. Westcott, you were concerned with getting something done, with making it work. With outside industry, quite rightly so, they were there to make a profit. There was this view, what will it do for the company? And can we get it done at a profit? And at times this was a completely different way of thinking than there was at Westcott. And again, I think that was down to the scientific staff. There was that air. Do things, learn, progress, as opposed to the cloth cap of, in certain cases, outside industry. As I said, I was conscious all the time that I was sort of carrying the torch for those who'd gone before me. I tried to think, again it's a cliche, but I tried to think, if so-and-so was faced with this, what would he do? And that was, and that helped. Again, it sounds hackney, but that helped. One person, again, I should mention, was at one time the head of engineering services, Bill Ollett. A marvellous man. I have never heard anyone say anything against him. He would come up, he would make you feel important, regardless of what your grade. He would ask questions about what you're working on. He may have known nothing at all about it, not have been interested, or he may have known about this thing in far greater detail than you would ever grasp. Made you feel interested. Again, another person that made Westcott what it was. And and his successors. Again, a lot of people had come up either as apprentices or they had started at lower levels and worked up. For Westcott that worked. On the occasions when they tried to bring someone in from outside, I don't think it worked. Because there is a period when somebody has to learn about the place, has to learn about people, you have to learn what you're doing. Then maybe after 6 months, a year, you may start to produce something useful. By which time people may have decided you're no good anyway. So that was an internal promotion, I think, for Westcott, as far as I can tell, worked because I saw other people promoted in all fields, not just in the DO. When we changed to Royal Ordnance, I think a lot of people became very wary of that change because the emphasis then, everyone thought, was on profit and profit alone. And my job as I became Chief Design Draftsman under Royal Ordnance, not Ministry of Aviation, Defence, whatever. My job changed. It was money all the time. You always had to be aware of money. Well, that's fine, that's okay. But I really didn't train to be an accountant. And when the time came, I think it was 92, they wanted to cut down on the number of people employed. I decided that was enough and started to apply for early retirement, which I got and have never looked back since.
Perfect.
Okay.
I'm just about to run off the end of the tape, so